Libor market model assumes that a forward rate follows a martingale geometric Brownian motion without drift. So Tf over F is sigma Ft, like this one. And because we want to set the future Libor, Libor is a type of interest rate. It is a proxy for risk-free rate in this model, in our lecture. So F is expected value of R tau t. This is generally not true in real life. This is generally not true. But we want to imagine that we are living in a world in which forward rate is expected future rate. It is interest rate between tau and t. And today is small t, so we don't know what is R tau t, which is don't know, but we want to imagine, we assume that we are living in the world in which this forward rate is expected future interest rate between tau and t. So forward rate that we set today, forward rate between tau and t is just expected value of interest tau t, which is, again, I want to emphasize this one because this is very important. This is generally not true, but we want to assume that we are living in the world in which this unit holds. So it is a kind of a risk-neutral world, we assume, but it is slightly different version of risk-neutral world. Anyway, because this forward rate is expected interest rate, this interest rate it follows log-normal distribution with mean of the forward rate and volatility variance sigma square t. And this kind of world is called T forward risk neutral measure. So it is kind of a risk neutral world, but we are imagining that in this particular risk neutral world, this expected future interest rate is the same to forward rate. Therefore, this was a particular different risk neutral world, and we call it T forward risk neutral world. Or the probability distribution over here is T forward risk neutral measure. Anyway, what we are trying to do is we are assuming that we are living in this world and we want to find a forward rate process or asset price that is consistent to real life. That's our goal. So we have this one. Therefore, this means R tau t is simply ft tau big T and exponential of this one. This is exactly consistent with our previous Black-Scholes case. Let's look at the Black-Scholes setting again here. Okay, look at this one. This in the Black-Scholes setting, future stock price is expected value of stock price, and so mean one part. Expected value of this part is 1. And it is exactly comparable to our Libor market model. So we decompose this future interest rate into the forward rate and the mean 1. This is in effect, it is one part. So again, this is because we are assuming that we are living in T forward risk neutral world. So it is expectation of R tau t and then mean one part. So we can decompose this one. Now this becomes very similar to Black-Scholes formula. Now, because it is very close to Black-Scholes formula, now let's do the derivative pricing. Suppose there is a caplit contract. Caplit is kind of a call option. You have because it's a kind of call option, you have the right to receive N multiplied by delta, multiplied R, T, big T, and to pay N delta RK. So this part is something you get. This part is you can regard it as exercise price in the call option. Here N is called the notional value. You cannot receive interest rate. You receive something, some money multiplied interest rate. That is what you receive. So we have to multiply the notional value, and this delta is a day count fraction for the prepayment. Thus, you can apply the formula such that caplit price of 0t because it's a call option, and we have this term. We can put this one outside. So n delta and z discount of f and d1 and rk and d2, right? So this one is similar to exercise price over here, and the D1 and D2 are all very similar to the case of Black-Scholes model. So D1 is ln f over rk plus 1/2 sigma square t and divided by sigma f root t, and D2 is D1 minus sigma root t. So exactly consistent with Black-Scholes model. We can we can look at it in more in detail. So basically, the pay-up, terminal pay-up, to emphasize this terminal pay-up, we can put big T over here. See, big T is N delta discount minus RT and expectation of max R and RK. If this is lower than this, you will not exercise option. You will exercise this cap rate only the interest rate at time interest for tau and t is greater than RK. So we have this one. Now you can undertake the same integration for the Black-Scholes formula. So this integration is C equal N sigma E R T and expectation C tau, and this expectation so integrate from minus infinity to infinity, and we need a plus over here because of max, and then we multiply probability density function. The form of this one exactly looks like Black-Scholes, the integration equation of Black-Scholes, so you can just iterate it. Therefore, similarly, you can drive the price for the floor, which is similar to put option. In case of put option, you can change location between these two. Then put option. And once you solve this one, this is called black model. So black model is basically this one, right? This is the black model for cap rate. This is the black model. This is the black model. Now, let me explain more about the interest rate, cap floor, cap rate, and floor rate. A series of cap rate, we just derive the price of cap rate. So if we have a collection of cap rate, it is called interest rate cap. And a collection or series of floor rate, which is like a put option version of the interest rate, is called the interest floor. Next is from Wikipedia. An interest rate floor is a series of European put option or floor rate on a specified reference rate. Reference rate usually Libor. Libor is usually, in most of the cases, Libor is reference rate. Now the buyer of the floor receives money if on the maturity of any of the floor rates, the reference rate is below the agreed strike price of the floor. So the mechanism is exactly the same to put option. And an interest rate cap is a derivative in which the buyer receives payments at the end of each period in which the interest rate exceeds the agreed strike price. An example of a cap would be an agreement to receive a payment for each month the Libor rate exceeds the strike price. The seller of a cap will continue to benefit from any fall in interest rate below the strike price, which makes the cap a popular means of hedging a floor rate loan, floating rate loan. Suppose you gave a floating rate loan to the other party. So what you receive as interest rate depends on current market interest rate. Therefore, when interest rate go down, you receive less money. Suppose like you put money in the bank at floating rate, then when interest rate go down, you receive less interest rate as an income. When interest rate go up, you are good. And if you don't like this situation, what you can do is you can sell a cap or caplet. And if you sold the caplet when interest rate go up, then you have to pay money to the other part. But then because you receive more money from the bank because of your floating rate loan, you can use that money to pay up the cap contract. On the other hand, the interest rate is low, then you can make money on the caplet contract, but you make less money in the floating rate loan, so they hedge each other. Therefore, if you are a seller of a cap, you have a good hedging position for floating rate loan. Another example. Now suppose you own a caplet on 6 months. It is important on 6 months, so it is 6 months. Delta is 6 months, it is delta. Right? 6 months USD Libor rate with an expiration date is 1st February 2007 and struck at 2.5%. So 2.5% is strike rate with a notional value, this is N, notional value $1 million. Then if the USD Libor rate set at 3% on February 1st, then you receive 1 million multiplied by 0.5, it is delta, it is 6 months rate, so it is over here. At the max 3% minus strike rate 2.5% 0, which is $2,500. Then when you receive $2,500, usually you receive 6 months later because it's 6 months rate, so you receive 6 months rate. Customarily, the payment is made at the end of the rate period. So it is struck in February 1st. So 6 months later, it is August 1st. August 1st. So you receive this money on August 1st. It is actually true for almost all interest rate contract. So for example, if you put money in the bank on February, then suppose February interest rate, if you put money, then on February interest rate, you receive money at the end of February. So it is customary to receive money at the end of interest rate period. So it is 6 months, so although interest rate is known from February to August, you receive money at the end of period, which is August. That is customary. So you receive this money at the end of interest period, which is August 1st.